This video covers D3 scales. The structure of this video is as follows: SVG coordinate space revisited, D3 scales, D3 linear scale, D3 linear scale domain, D3 linear scale range, and the summary. Alright, let's get started. SVG coordinate space revisited. The SVG element is commonly referred to as the SVG viewport. Things within the SVG viewport's dimensions are visible. Things inside the SVG tags, though outside the viewport dimensions, are not visible. When we talk about the viewport and what is inside, we will be talking about units, not pixels. The SVG width and height are the width and height of the viewport. This setup tells the browser to set aside an area of 200 pixels by 200 pixels in the document for SVG graphics. This way, the browser knows how to place the rest of the elements in the HTML document. This setup also tells the browser that the interior of the SVG viewport is 200 units wide by 200 units tall. The width and height for the SVG element that we choose are completely under our control. We can make it as big or as small as we want. There are two ways to think about how to choose the dimensions of the SVG viewport. One is to let the data tell you how big to make it. Two is to choose hard numbers and to scale the data up or down accordingly. In this video, we look at way number 2, choosing hard numbers and scaling the data up and down accordingly. D3 scales. D3 provides 3 types of functions that map an input domain to an output range. The quantitative scales are for real numbers. The ordinal scales are discrete domains such as letters of the alphabet. The time scales are an extension of the quantitative scales that use the JavaScript date objects. All of these scales take in data and convert it to a usable set of output. Sometimes this means scaling up the data, and sometimes it means scaling down the data. In maps, the outside of the map can be measured in inches or centimeters. Measuring the inside in inches or centimeters completely misses the point without a scale conversion. On the inside, 1 unit could be 1 inch, a kilometer, a mile, or something different. So D3 provides the way for us to take advantage of this type of scaling. It's the equivalent of us telling D3 that 1 inch equals 1 mile, and then having it calculate all of the relevant information for us. Obviously, you could do the math yourself. I prefer to let D3 do the math for me. D3 provides many kinds of ways to transform data through scales. This video will focus on the linear scales. This allows us to explore the basic concepts of D3 scales. Once we understand those, the rest will be easier to comprehend. D3 linear scale. D3 quantitative scales are for the continuous input domain such as numbers. The mapping is linear in that the output range value y can be expressed as a linear function of the input domain value x. So we get y equals mx plus b. Before we get into the math, let's take a step back. We start with the SVG container. It has to be 200 pixels wide by 200 pixels tall. This is the room it has in the HTML web page. We cannot change the size. Then we have the myData array. The data process we are visualizing produces 4 n, p coordinates. For the data snapshot we are currently looking at, it has produced numbers bigger than 200 for both n and p. Why does 200 matter? It matters because if we use a 1-to-1 scale, all of the points that have n or p values greater than 200 will not be visible in the SVG viewport. Going back to the SVG viewport, things within the SVG viewport's dimensions are visible. Things inside the SVG tags, though outside the viewport dimensions, are not visible. So anything inside of the box defined by 0, 0, 0, 200, 200, 0, and 200, 200 are visible. And anything outside of the box defined by 0, 0, 0, 200, 200, 0, and 200, 200 are not visible. What we want to find is what 1 unit is equal to such that all of the data fits into the SVG container viewport. This way, all of the data will be visible within the 200 by 200 viewport. This is where the math comes in. The x's that we take in from our data have to fit into the 200 by 200 box, which means that the maximum that y can be is 200. So we want to translate our data so that max p and max n are 200 instead of 400. To do that, we could divide the data by 2, such that every new unit is equal to 2 old units. This does the trick in that the new data fits into the SVG viewport. And this is the math. Take an old unit and divide it by 2 to get a new unit. Notice that the B disappeared because we are not adding or subtracting anything to go from old units to new units. Rather than having to do this math, we can get D3 to do the math for us. Using the D3 scale linear, we can tell D3 that the initial data covers 0 to 400, and we want it to cover 0 to 200 after it has been scaled. This figures out what the correct math for the right M and B should be. Let's take a look at the domain operator for the D3 linear scale first. D3 linear scale domain. In this example, the domain takes in one array that contains 2 numbers in it. Note, these 2 numbers can be anything you want. These numbers should cover all of the possible values of the data you are using. D3 scale linear maps a real number line to a second real number line. To visualize this, imagine a line that has numbers. If we do this, then we can talk about the numbers being to the left or to the right of each other. In this instance, A is to the left of B, B is to the left of C, and A is to the left of C. We can also say that C is to the right of B, B is to the right of A, and C is to the right of A. If the data we get exists only between A and C, including A and C, then we can say the domain of line 1 is A, C. Which if we use directions means all of the numbers to the right of A up to and including C, but nothing to the right of C. Why do we use directions instead of bigger than or less than? Because the domains 0, 400 and 400, 0 are both valid. The domain 0, 400 specifies that as we go to the right, the numbers increase. The domain 400, 0 specifies that as we go to the right, the numbers decrease. Most people think of number lines where numbers increase as you go to the right. However, there is nothing to stop us describing a number line where numbers decrease as you go to the right. After all, in non-SVG coordinate space as y increases you go up, but in SVG coordinate space as y increases you go down. So it is best to think of domains as all the numbers to the right of the first number up to and including the second number, but not to the right of the second number. So the domain is just telling D3 all the possible values that the data will cover, from the leftmost value to the rightmost value. Next, we cover the range. D3 linear scale range. In this example, the range takes one array that contains 2 numbers in it. Note, these numbers can be anything you want. These numbers should cover all of the possible values that you want the data to be mapped to. D3 scale linear maps a real number line to a second real number line. To visualize this, imagine a line that has numbers. Just like we did with line 1, we can talk about the numbers on line 2 being to the left or to the right of each other. In this instance, D is to the left of E, E is to the left of F, and D is to the left of F. We can also say that F is to the right of E, E is to the right of D, and F is to the right of D. The range is thus the result of the transformation from line 1 to line 2. The leftmost element in line 1 gets transformed to the leftmost element in line 2, and the rightmost element in line 1 gets transformed to the rightmost element in line 2, and the middle elements in line 1 get transformed to the middle elements in line 2. When we tell D3 what the range is, we are defining what the leftmost and rightmost elements are in line 2. Why directions for the range as well? Because the scale on the screen is also valid. This means as we move from 0 to 400 on line 1, we want to move from 200 to 0 in line 2. When would we want this to happen? On the SVG coordinate y-axis. For a data visualization, people expect that as the y-axis variable grows, that it will go up. So as the y-axis variable goes from 0 to 200, the SVG coordinates drawn should go from 200 to 0. Which in the SVG coordinate space means that they will go from the bottom of the graph to the top. And that is the domain and range of the D3 linear scale. The summary. This video covered SVG coordinate space revisited, D3 scales, D3 linear scale, D3 linear scale domain, D3 linear scale range, and the summary.